In the rapidly evolving world of military technology, artificial intelligence, AI, is becoming an indispensable tool. The integration of AI into military weapons and systems promises to enhance capabilities, improve decision-making, and reduce the risks faced by human soldiers. Autonomous drones, the XQ-58A Valkyrie. The XQ-58A Valkyrie, developed by Kratos Defense and Security Solutions, is a cutting-edge autonomous drone that showcases the transformative impact of AI on military aviation. This stealthy unmanned combat aerial vehicle, UCAV, features a clean sheet design with a trapezoidal fuselage, swept-back main wings, V-shaped tail, and an air intake above the fuselage, making it difficult to detect and track. The Valkyrie is powered by a turbofan engine capable of delivering a maximum thrust of approximately 2,000 pounds, allowing it to fly at a cruise speed of Mach 0.72 and reach altitudes ranging from 50 feet to 45,000 feet. With a length of 30 feet, a wingspan of 27 feet, and a dry weight of 2,500 pounds, the XQ-58A can carry a maximum payload of 600 pounds internally and an additional 600 pounds on its wing stations. The drone's advanced AI algorithms, matured over millions of simulation hours, enable it to execute a wide range of missions with significant autonomy, including reconnaissance, electronic warfare, acting as a decoy, and engaging targets with its own missiles. The XQ-58A is part of the U.S. Air Force's Skyborg program, which aims to develop autonomous capabilities for future aerial combat, allowing it to work alongside manned aircraft to enhance mission flexibility and increase the operational reach of the Air Force. The Valkyrie represents a major improvement in unmanned aerial vehicle, UAV, technology, demonstrating the potential for AI to manage combat scenarios without direct human intervention. Its low-cost, high-performance design, combined with its autonomous capabilities, makes it a valuable asset in modern warfare. AI-powered fighter jets, the X-62A Vista. The X-62A Vista, variable in-flight simulation test aircraft, is an experimental fighter jet that has been extensively modified from the F-16 Fighting Falcon platform to serve as a testbed for advanced artificial intelligence, AI, and autonomous flight capabilities. Managed by the U.S. Air Force Test Pilot School and the Defense Advanced Research Projects Agency's DARPA, Air Combat Evolution, and ASA program, this unique aircraft has demonstrated its ability to engage in AI-driven dogfights, showcasing its impressive autonomous combat skills. The X-62A Vista is equipped with a turbofan engine capable of delivering up to 2,000 pounds of thrust, allowing it to reach speeds of Mach 0.72 and altitudes ranging from 50 feet to 45,000 feet. With a length of 30 feet, a wingspan of 27 feet, and a dry weight of 2,500 pounds, the aircraft can carry a maximum payload of 600 pounds internally and an additional 600 pounds on its wing stations. The key to the X-62A Vista's autonomous capabilities lies in its advanced AI algorithms, which have been matured over millions of simulation hours. These algorithms enable the aircraft to execute a wide range of missions, including reconnaissance, electronic warfare, acting as a decoy, and engaging targets with its own missiles, all with a high degree of autonomy and without direct human intervention. The success of the X-62A Vista in these AI-driven dogfight tests has underscored the potential of AI to perform in high-stakes combat environments, providing a glimpse into the future of aerial warfare where AI-operated jets might complement or even replace human pilots. This technology could have far-reaching implications for the U.S. Air Force's next-generation air dominance program, which aims to develop a system-of-systems approach to air superiority, integrating manned fighters with autonomous support platforms. Loyal wingman drones. The concept of loyal wingman drones is another significant advancement in AI military technology. These drones are designed to accompany manned fighter jets, providing additional firepower, conducting reconnaissance, and performing other supportive roles. The U.S. Air Force's Collaborative Combat Aircraft (CCA) program is at the forefront of this development, seeking to pair human pilots with AI-driven drones to enhance overall combat effectiveness. These drones, like the XQ-58A Valkyrie, can operate semi-independently, making decisions in real-time based on the evolving dynamics of the battlefield. This human machina teaming aims to maximize the strengths of both human and AI capabilities, leading to more flexible and resilient combat operations. Robot ground units. The U.S. Army is actively integrating AI into ground-based robotic units to support infantry operations. Examples include the Ghost Robotics unmanned ground systems, which can perform tasks such as reconnaissance, logistics support, and mine clearing. These robots are part of the Army's broader initiative to create human-machine integrated formations, enhancing the capabilities of soldiers while reducing their exposure to danger. The use of AI in ground robots enables them to navigate complex terrains, identify threats, and execute tasks autonomously. This technological integration not only offloads risk from human soldiers, but also provides them with critical information for better decision-making on the battlefield. AI-enhanced missile defense systems. Missile defense is another area where AI is making significant strides. AI-driven systems are used to detect, track, and intercept incoming missiles with greater precision and speed than traditional methods. These systems leverage machine learning algorithms to analyze vast amounts of data in real time, identifying potential threats and deploying countermeasures more effectively. For instance, AI has been integrated into missile defense systems used to protect strategic assets in conflict zones, enhancing their ability to respond to threats. This improved responsiveness and accuracy can be crucial in preventing attacks and safeguarding military and civilian infrastructure. Autonomous underwater vehicles, AUVs. In naval warfare, AI is revolutionizing underwater operations through the development of autonomous underwater vehicles, AUVs. These AI-driven submarines are used for tasks such as mine detection, underwater reconnaissance, and anti-submarine warfare. They operate independently, making decisions based on their programming and real-time data analysis, providing enhanced situational awareness and operational capabilities to naval forces. AUVs equipped with AI can navigate underwater environments, identify and neutralize threats, and carry out prolonged missions without direct human control. This autonomy is particularly valuable in undersea warfare. One of the key capabilities of AI-powered AUVs is their ability to process and analyze vast amounts of data, including sonar, imagery, and environmental information. This enhanced situational awareness allows AUVs to make informed decisions, adapt to changing conditions, and execute their missions with a high degree of precision and efficiency. AUVs can be deployed in swarms, with each unit contributing to the overall mission and sharing information to create a more comprehensive operational picture. This collaborative approach, enabled by AI, enhances the effectiveness of naval forces in detecting and neutralizing underwater threats, such as mines, enemy submarines, and other maritime hazards. As the technology continues to evolve, the integration of AI-driven AUVs into naval warfare is expected to increase, providing commanders with a powerful tool to maintain dominance underwater. Swarming drones. Swarming technology powered by AI is being utilized to coordinate groups of drones that can execute missions collectively. The U.S. Army's Project Convergence has demonstrated the use of drone swarms in battlefield scenarios where multiple drones work together to conduct reconnaissance, electronic warfare, and precision strikes. These swarms can adapt to changing conditions in real time, reconfiguring their formation and strategy based on the mission requirements and the actions of the enemy. AI algorithms enable these drones to communicate and collaborate, creating a formidable and flexible force multiplier on the battlefield. AI is not just an enhancement to existing military capabilities, it is a transformation that is reshaping warfare. This is just the beginning as AI continues to push the boundaries of what is possible in military technology. The future of warfare will undoubtedly be intelligent, autonomous systems that work alongside human soldiers to achieve and maintain security in an ever-changing global landscape. Thanks for watching, and don't forget to like and subscribe.